video, I will be discussing about the equations of motion for a body moving with uniform acceleration. Okay, these equations of motion are valid only when acceleration is constant and motion is constrained to a straight line. That is, these equations apply to only those bodies which are traveling with uniform acceleration and their motion is constrained to a straight line. In reality, there are no bodies which actually qualify these conditions. But by performing certain assumptions, we can apply these equations to certain situations in real life. For example, in the case of a car traveling through a road, the degrees of freedom for the car is only one. That is, it will be traveling towards the left or towards the right. In this case, we can make an assumption that this car is traveling in a straight line and apply these equations of motion. There are three ways to pair these equations of motion. First one is the velocity-time relation. In this equation of motion, a relationship between velocity and time is shown. Then there is the second one, which is the displacement time relationship. Then third is the velocity displacement. In this whole presentation, these are what these alphabets denote. That is, A is equal to acceleration, V is equal to final velocity, U is equal to initial velocity, T is equal to time, S is equal to displacement. Now let's see the first equation of motion. That is the velocity time. The relation between velocity and time is a simple one during uniform motion. Uniform accelerated straight line motion. That is, there is always a constant uniform rate of change in the velocity. That is, the longer the rate, the greater the change in velocity. For example, if the velocity is 2 meters per second for the first 1 second, then for the second it will be 4 meters per second. An object already started with a certain velocity, then its new velocity would be the old velocity plus this change. Hence we can say that final velocity minus initial velocity divided by time is equal to acceleration. That's the acceleration. That's the formula for acceleration. From this rearranging, we get 80 is equal to v minus. Again rearranging, we get final velocity is equal to initial velocity plus the product of acceleration and time, which is the first equation of motion, which shows the relationship between velocity and time. Here velocity is directly proportional to time. Now this is the second equation of motion connecting displacement and time. Displacement is directly proportional to time and directly proportional to velocity, which is directly proportional to time. That is, velocity is directly proportional to time and displacement is also directly proportional to time and also to velocity. Hence we can say that time is displacement is directly proportional to square of time. That is, if a body travels 3 meter in the first second, then in the second the body will travel square. That is 9. Now the formula for average velocity is equal to displacement by time. According to mean speed rule, average velocity is equal to initial velocity is equal to the sum of initial velocity and final velocity, the whole divided by 2. That is, by substituting the equation we get v plus u by 2 is equal to s by t, where s is the displacement. Now we substitute the first equation of motion for the final velocity. That is v is equal to u plus at. That is s is equal to t into u plus at plus u divided by 2. On rearranging this, we get the second equation of motion. That is s is equal to ut plus half at square. Oh, this is the third equation of motion, which is the velocity displacement, in which the relation between velocity and displacement is given. Velocity is directly proportional to time when acceleration is constant, which is the first equation of motion. Then the second equation is motion, which gives the relation between displacement and time, which is displacement is directly proportional to the square of time. Now combining these two statements gives rise to the third equation of motion, which is independent of time. That is, displacement is directly proportional to the velocity whole square. The velocity displacement equation is particularly applicable in the case of driving safety. That is, when you double the speed of a car, it takes 4 times more distance to stop it. Triple the speed, you will need 9 times more distance. Now we can see the derivation of the third equation of motion. From first equation of motion, time is equal to v minus u by a. And now we substitute the value of t in second equation of motion and we get this. That is s is equal to u into v minus u by a plus half into a into v minus u by a the whole square. Rearranging this, we get 2as is equal to 2uv minus 2u square plus v square plus u square. 2uv minus 2uv 0, 2 minus 2u square plus u square minus u square. That is v square minus u square is equal to 2as. Rearranging this further, we get the third equation of motion, that is v square is equal to u square plus 2as.